In this screencast, we will discuss our first gas law, which is Boyle's law. As you can see from the graph that's shown here, as pressure increases, the volume of a gas decreases. So Boyle's law shows an indirect or an inverse relationship, where pressure increases, volume decreases, and conversely, where pressure decreases, volume will increase. The variables in Boyle's law are pressure and volume. As you can see in this diagram, in the first example, we have 5 particles of gas, and they are in a large container, and so the volume of the container is 1 liter, and the pressure is 100 millimeters of mercury. When we push down on the lid, increasing the pressure to 200 millimeters of mercury, we decrease the volume by half a liter. Notice here that the particles are bouncing off of the walls of the container with more force and more frequently, and this is what causes the pressure to increase. It's important to note that there are various units that we can use for pressure. Pressure units can include atmospheres, kilopascals, PSI, or pounds per square inch, millimeters of mercury, or torr. We will be exploring how those pressure units relate to each other in a later screencast, but for now, what I need you to do is make sure whenever you're dealing with Boyle's law that the pressure units are the same. So both pressure units have to be in atmospheres, or PSI, or torr, etc. The constants in Boyle's law are the temperature and the amount of gas, or the mass. Notice in this example that the temperature doesn't change. It stays steady at 300 Kelvin, and that the number of particles inside the container does not change. Okay, so we still have the same number of gas particles, but when we decrease the volume, we've increased the pressure because that same number of particles is having more collisions. So again, in Boyle's law, the constants are going to be temperature and amount of gas. Our equation for Boyle's law is P1 times V1 equals P2 times V2. And so here we start to see why it's really important that our pressure units are the same. So we need to have atmospheres on both sides of our equation, or kilopascals on both sides of our equations. What we cannot have is atmosphere as the unit for one pressure and torr as the unit for another pressure. So our units have to be consistent. And so here we can really start to see that as I increase the pressure, I'm going to decrease the volume because that's the only way to have the same value on both sides of my equation. So let's try this sample problem together. Sample of neon gas occupies a volume of 7.5 milliliters at STP. What would the new volume be if the pressure were changed to 95.7 kilopascals? So when I look at a gas law problem, the first thing I want to do is list my variables. So here I have P1, V1, P2, and V2. Now let's look in the problem and see if we can identify these variables. It says that my volume initially is 7.5 milliliters at STP. STP is actually a measure of pressure. So I'm going to use kilopascals, so my first pressure is going to be 101.3 kilopascals. And my volume at that pressure is 7.5 milliliters. Now I'm told that I'm going to change the pressure to 95.7 kilopascals, and I'm asked to find my new volume. So my second pressure will be 95.7 kilopascals, and my volume 2 will be X. Now all I need to do is plug those values into my equation. So I'm going to have 7.5 times 101.3 equals X times 95.7. To solve for X, I'm going to divide both sides of my equation by 95.7. So 7.5 times 101.3 divided by 95.7 will give me 7.9 milliliters. I know I want my unit to be milliliter because that's the unit of my other volume. At the end of your notes, try to solve this gas law problem. Remember to make sure that your pressure units stay consistently the same. Your answer needs to include units, and make sure you show all of your work.